we're going to go ahead and take a look at confidence intervals. And we're going to try to help you make sense of what confidence intervals are. These will be the main things that we'll be looking at. So let's take a look at this. Suppose we have this survey that was done and we have these results. The conclusion was that 45% of the Americans reported having health insurance through their employer. Well, how accurate is that? Well, it's a fairly large sample, so I would expect it to be fairly accurate. But is it exactly the same as our population parameter? As in, is it the exact proportion that matches the percent of Americans that have health insurance through their employer? It's probably not exactly 45%. It's more likely really close to it, but it's probably not exactly 45%. So that's why we typically want to go ahead and use an interval estimate. In other words, we want to give a range of values, like from this value to this value, that will likely contain our population parameter. Whether that's our population proportion or our population mean depends upon the problem. Now, there's a couple ways to really represent that interval. One of the common ways is to take our statistic that we get from our sample, the mean or the proportion, and then go plus or minus our margin of error, where the margin of error really reflects how precise our interval estimate is to our population parameter. So going back to that original situation, later on it says with a margin of error of plus or minus 1%. So in other words, our interval estimate would be that 45% plus or minus 1%. So 1% on either side of 45%, which we could write then as a 44 to 46% interval. So your interval estimates and confidence intervals can be written as your statistic plus or minus your margin of error, or you can actually work out what the two numbers are, and you can say it's going to be between 44 and 46%. So we would more likely say the percent of American adults getting their health insurance from an employer is probably between 44 and 46%. So let's take a look at text messages. So we have our average and we have our margin of error. So to give our interval, we would actually have to go ahead and take our 45 and add and subtract 12.2. So you could write it like this here, but more likely we want to write it out as in what two numbers is it between. So we want to go 41.5 and subtract the 12.2, and that's where the 29.3 comes from. And we want to take the 45.5 or 41.5 and add 12.2, and that's where the 53.7 comes from. So we would say we anticipate that the number of text messages sent per day is probably between 29.3 to 53.7 text messages per day. So here we're looking back at the Romney-Obama presidential election polling results. So we have our sample size, we have our margin of error, and we have those that voted for Obama and, or not voted, but we're planning on voting for Obama, and we're planning on voting for Romney. So that's our margin of error. So why do you think the margin of error is smaller for the ABC or the Gallup poll than the ABC? So here's our Gallup poll right here. Margin of error is this. Here, our margin of error is this for the ABC. Well, it's all related to our sample size. The larger your sample, the smaller your margin of error. The smaller your sample, the bigger your margin of error. So use the Gallup poll to calculate an interval estimate for the proportion. Well, we're going to actually go ahead and calculate our interval for each and every one of these. So when we do our first one, we're going to go 46 plus or minus 3. So we get this interval here. So you go 46 minus 3, and that's 43. 46 plus 3, and that's this one here. So quickly go ahead and do all the rest of them, and then continue the video. So here is our Gallup poll. Here's our ABC. Here is our CNN. And here's our IBD. So how close were these intervals to the true population parameter? As in, how close are these to the actual number of people that voted for Obama? Well, this is what Obama was. Did our intervals contain that? Well, if we go back and list those again, you can see that yes, they are in some of them, but not in others. So it's not in the first one we had. It is in the second one because 50.4 is between these two numbers. It is in the third one down here because 50.4 is in between these numbers. It's in the fourth one, but it's not in the bottom one. So basically, as we go back to that slide, it's likely that your interval will contain the true population parameter, but it's not a certainty. So we often will end up giving our interval estimate with a probability that we're capturing that true population parameter. And we're going to get to that more later here. So how do we determine that margin of error? Well, it's related to the sampling distribution, which remember is our standard error. So if we go and do our sampling distribution and we go this and do the standard deviation of that sampling distribution, that's your standard error. And that's what we use to help us find our margin of error. Our confidence interval for our parameter, whether it's a mean or a proportion, is the interval that's computed from our sample data by a method that will capture that population parameter for a specific proportion of all samples. So let's continue on and we'll help you make sense of that. Our success rate of capturing that population parameter is known as our confidence level. Sometimes it's 90%, so it's often 95%, sometimes it's 98% or 99%. We typically want to use a higher percentage because we want to be fairly certain that we're capturing that population parameter. And once again, 95% interval will contain the true population parameter, 95% of all the samples. We're not, so 95% is kind of the one that's often used, but it's not the only one. So on the side over here, we did some sampling. We have our fixed parameter, which is right here at the black line going through the middle. Each one of these is representing a confidence interval. You'll notice that if it's in green, the confidence interval does span and go over the true population parameter. If it's in red, the interval is outside of where the population parameter is. You'll see that the majority of the time, our intervals do capture and contain that population parameter, but there's a few times it doesn't. So once again, our statistic that we get will vary from sample to sample. And that's what we're looking at with these little round circles over here. And those will vary, and we're not sure if our statistic is really close enough to that population parameter to capture it or not. But we know the majority of the time that it will. So the interval will vary because of our statistic, but the population parameter doesn't. And so 95% of our 95% confidence interval will capture the true truth, which is our population parameter. So going back here to our population or our confidence interval, if we wanted a 95% confidence interval, and we know it's going to be our statistic that we get plus or minus our margin of error, how would we actually figure that out? Well, if you think back to chapter 2 in our 95% rule, we had said we had to use two of those standard deviations. And for our confidence intervals, that standard deviation is of our sampling distribution is called our standard error. So a 95% confidence interval will be our statistic that we get from our sample, that sample mean or that sample proportion, and we'll add 2 times our standard error, or we'll subtract 2 times our standard error. It's always our statistic plus or minus 2 times our standard error for our 95% confidence interval. So here we have our proportion, we have our standard error. Go ahead and try to give us our 95% confidence interval. So we have to take our statistic, go plus or minus 2 times our standard error. So we're going to take our statistic of 0.68, go plus or minus 2 times 0.01, which is 0.86 plus or minus 0.02. We could actually add and subtract these numbers, and that's where we get the 0.4 or 6, sorry about that, 0.84 by taking 0.86 minus 0.02, and we get the 0.88 from taking 0.86 and adding 0.02. So this would be our 95% confidence interval. So now let's go ahead and try to figure out what does our confidence interval tell us. 95% of the samples will yield intervals that contain our true population parameter. So we are 95% sure or 95% confident that our confidence interval will contain the truth, that actual parameter. So in the context of this last problem, we would say we're 95% confident that the true proportion of all Americans that consider the economy to be a top priority in January 2012 is between 0.84 and 0.88. There's kind of 3 things you need to have in a confidence interval. You need to have your confidence level, which is our 95%. You need to have your interval of estimate, which was given to us here at the end. And then what it is we're talking about. And that's what we're saying here with the true proportion of blah, 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 all the way to here. So you got to have your confidence level, what it is you're describing, and remember, it's always something about your population parameter, either your population proportion or your population mean. And you need to have your interval estimate at the end. Typically, it's at the end. So go ahead and take a look at this one here. Try to figure out your confidence interval and then go ahead and interpret that confidence interval, meaning write out what it's supposed to look like and mean. So go ahead and try to do this on your own if you can. So pause the video. So what does that mean? Well, we need to take our statistic, go plus or minus 2 times 1,000, our standard error, for our 95% confidence level. So we go 11,600 minus 2,000, and that's where we get to 9,600. 11,600 plus 2,000, that's where we get to 13,600. So what's that really mean? We're 95% confident that the average amount of carbon stored in each square kilometer of the tropical forest is between 9,600 and 13,600 tons. Once again, we need to have those three things: our confidence level, our interval of estimate, and then what it is about our population that we're describing. So, some people will say this is a correct statement, but it is not. Right now, it states that we're 95% confident that our interval will contain, we would want to say that we're 95% confident that our interval will contain the true population proportion or mean. Now, this one is false because we're 100% sure it contains the sample mean because that's what we calculated from our sample. We need to say that we're 95% sure that the mean of the population will fall within this one down here. Take a look at it and try to see if you can figure out what's wrong. On this one, we would want to say that we're 95% confident or 95% sure that we are containing the population parameter. Our population parameter doesn't bounce around. It's our, or move. It's our sample. If we would take a different sample, it's the sample statistic that changes. And so we're 95% confident or 95% sure that we would contain that. So as a review, we take a sample, we get our statistic, we do our sampling distribution, we calculate the standard error using technology, which is the standard deviation of the sampling distribution, use that to get our margin of error, and that helps us with our confidence interval. So just a quick review of what's going on. However, we have one problem to be answered in the next video.